Okay, so problem number 6 says to see the feasible options, to see to see all the feasible options, you can use a visual display. So they want us to graph it. Graph your inequality from number 3. Uh-oh, I wrote down equality, not inequality. So they want me to graph this, okay? This equation is in what form? It's in standard form. How do you graph a standard form equation? Well, the pops into my mind um, two things that we could do. We could put it in slope intercept form, and slope intercept form here would be m, and that's why I hate the fact that they used m. Because slope intercept form is y equals mx plus b. But here, this case, our y would be the number of meals, and then our slope, whatever our slope is, and our x would be t, and then we would have our y-intercept. So I'm going to stay away from that, but I could, if I wanted to do it this way, I would just have to solve for m. So one way I could do it would be to solve for m. The other way I could do it is use your intercepts. Okay, when it's in standard form, it's really easy to find your intercepts. You just plug in 0 right here, solve for m, plug in 0 right here, solve for t. So you can solve this. It's in standard form right now. If you solve for m, I'm not showing my work, but if you solve for m, you're trying to get m by itself, it's going to be m is less than or equal to, we would subtract 100 and divide by 40. So it would be 5 over 2. I think it would be how it would reduce down. 5 over 2 t, and then it would be plus 34. So I guess I should show it. 100t plus 40m equals 1360. I'm sorry, is less than or equal to 1360. We're solving for m because the m is on the on the y-axis. So we got to get the y by itself. In this case, this is your y. So we got to get that by itself. So we do 40m is less than or equal to negative 100t. Yep, that is going to be negative. Negative 100t plus 1360. I just subtracted, won't let me write my 0 right there. I just subtracted 100 from both sides. Then I'm going to divide everything by 40. And that's going to give me m is less than or equal to, reduce that, that's 10 over 4, that reduces to 5 over 2, t, and then that 1360 divided by 40 reduces down to 34. So that's how I got that number. Now, that's one way you could do it. Now you've got the y-intercept, you go up to 34, but then you have to go down 5 over 2. And I don't know how these are. Yeah, these are 1, 2, 3, 4. So I could do it. Down 1, 2, 3, 4, 5 over 2. There's my next dot right here. 1, 2, 3, 4, 5 over 2. So I could keep going like that, and I just may, but I also want to remind you that you could also find it by doing 40m is less than or equal to 360. So m is going to be less than or equal to 34. So on the m axis, you go to 34, and then you do 100t, because I'm plugging in 0 for each one. Here I plugged in 0 for t, gave me this. Here I'm plugging in 0 for m. I'm going to get 100t is less than or equal to 1360. And then when I divide both sides by 100, I get 13.6. So that means on my t-axis, I'm going to go to 13.6. All right, so you can continue going down 5 over 2, down 5 over 2. I have enough points now. I can graph my line. I can get my ruler to line up. Divide it by 100. Yeah, it should be 13.6. Maybe my ruler. Oh no. I moved everything. Okay, so let me try again. Okay, that's a little bit. Oh no, that's way off. I don't know. Something's wrong. I'm gonna move my ruler because I don't know what I'm doing wrong. Did I do 1, 2, 3, 4, 5 over? Oh, I didn't go over 2 on this one. That's what happened. I just went over 1. So that didn't line up. So let me try again. 1, 2, 3, 4, 5 over 2. So that's where my dot should be, right there. 1, 2, 3, 4, 5 over 2. Now all of these should line up. I need to move it over here. Not quite as easy as using one that you can touch. Not quite that easy. Oh, good Lord. Shouldn't be this hard though. Okay, that's going to be close enough, people. Draw my line. Okay, so that is the graph of m equals -5 over 2. It says, what is the boundary line of the graph? So I think they want me to say, what does this boundary line right here and all the points on it, what did that represent? That represents spending all the money. So if you are a point, so this point right here, what was that? That was 4 tickets. If I buy 4 tickets, I can eat 24 meals. So 424 is 4 tickets and 24 meals. That will spend all the money. That equals $1,360. But because this is an inequality, we don't just draw the line, we draw a solid line because the bar is underneath it, but we also do some shading, and the shading goes below the line. And why does the shading go below the line? The shading should go below the line because do we care if we have money left over? No. So one of the things that we did over here in number 4 was say if he eats 2 meals a day for 5 days, how many tickets can he buy? We said 9 tickets and 10 meals. So let's go over here and see where that graphs. 9 tickets and go up to 10 meals. Here's that point right there. Here's 9 tickets and 10 meals. Is that point on the line? No, it's not. But is it in the shaded section? Yes, it is. And since that point is in the shaded section, it is still considered a solution because we don't care if if we spend less money. We just don't want to spend more money. So which half plane should be shaded? Below the line. Because how did you decide? Because that is less, that is spending, less than $1,360, and that's okay. Spending less is okay. Write your responses is in this form. So what we said 9 tickets and 10 meals is in the shaded section. And for problem number 5, what did we do? Problem number 5 said we could do 5 tickets or 21 meals. We could buy 5 tickets. We could eat 21 meals. And so if you go over here and plot that, you see 5 tickets, and we can go all the way up to 21. Boy, that's just barely under that line. So these are this is the shaded, this is the graphical representation of it's feasible. So any point over here would be feasible, and if it's below the line, it's feasible and you have money left over. If it's on the line, you have spent all of your money, and if it's above the line, this is too much money. You have spent too much money up here. So if he tries to go to 12 shows and eat 21 times, if he goes to, he buys 12 tickets and eats 21 times, he has spent way too much money. All right, this right here is 4 tickets and 11 meals. He's got lots of money left over. So the closer you are to the line, the less money you'll have left over. If you're on the line, you spent exactly. So what was this one right here? This is 8 tickets and 14 meals. That will spend every bit of the money. Is there another one? This one right here looks like it might be right on the line. This one right here looks like it might be right on the line. So 13 tickets and 2 meals. If he doesn't get very hungry, in 5 days, 2 meals, I think I'd starve to death. I know I'd faint. So that's the graphical, the graphical representation of all of this. And in my next video, I'm gonna show you how to do all of this on Desmos.